Hello everyone, and welcome you all to this amazing platform of Knowledge Planet powered by Physics Wallah. And today, in this particular lecture, we are going to do our number system in one shot. So, welcome you all, and I'm your math educator Shivangi Rajput. So, let's see what is our target of today. Right, so basically what we are going to do in this particular lecture, we are going to do something really important, that is all the concepts of your number system, that is starting with your all the numbers which are included, right? Especially we will focus on rational numbers and your irrational numbers, right? So we are going to focus on these two numbers because rest of the numbers you have already done in your junior classes. The second thing that we are going to do is to bifurcate the numbers depending on different types of these. Then we are going to discuss about number line, and can we plot irrational number on number line? That is something which we are going to do, right? The next thing that we are going to learn about is the decimal expansion, right? We are going to learn about the decimal expansion of different numbers. And after that, we will be learning about laws of exponents and basically what all are the laws of exponents and how they're applied on the irrational numbers. So this is something that we are going to discuss. So let's start with it. The very first thing that we have is a number line. When we were in junior classes, we learned that the number line starts from 0 and goes to the positive side, that is 1, 2, 3, 4 and 5, 6 and so on, like till positive infinity. And after that, we realized that there are integers as well, that is negative of those numbers, and this is where the negative number line falls. All these points on this number line represents one unique number. Let it be rational or irrational. So before starting with that, let us quickly recall what are the different types of numbers, right? So we know about natural numbers, that is denoted by the letter capital N. Now what are natural numbers, students? We already know the counting numbers are known as your natural numbers, that is your 1, 2, 3, 4, 5, 6 and so on till endless. Right. The next thing we have is the whole numbers. Natural numbers, if in natural numbers we add a digit, that is 0. So that collection of number forms your whole number, that is 0, 1, 2, 3, 4, 5, 6 and so on. After that we have integers, that is denoted by the letter capital Z, that is Z. And what are integers? The whole numbers, that is 0, 1, 2, 3, 4, 5, 6 and so on, including your negative of those numbers, form your integers. After that we have rational numbers, right? Now what are these rational numbers? Basically rational numbers are of great importance in this chapter. So rational number basically are the numbers that can be represented in the form of P by Q, that is 1 by 2, minus 3 by 4, 7 by 8. Now you might wonder that what is the difference between rational number and then fractions? Fractions are also 1 by 2, 3 by 4. What is the difference, right? So where fractions only includes a positive number, rational number includes your negative numbers as well, right? And in rational number, the Q cannot be 0. That is the denominator of that particular number cannot be 0. And real numbers, all these numbers collectively are called real numbers. But apart from these numbers, there is also one group of number that comes under real number, right? Those are your irrational numbers. Now what are irrational numbers? The numbers that cannot be expressed in the form of P by Q, or basically we can say that the numbers which are specifically have a decimal expansion. So decimal expansion we are going to do by the end of the lecture, but yeah, let me tell you that irrational numbers are the numbers basically whose decimal expansion is non-terminating, non-recurring. Now what are these terms we are going to discuss in this lecture? So basically over here we can see that real numbers are what? A collection of rational numbers and irrational numbers. Now rational number includes these numbers, that is under rational number comes integers, under integers come whole number, and the smallest collection is of natural numbers, right? And the biggest collection over here is of rational numbers. Both rational numbers and irrational numbers are known as real numbers. Now you might wonder that apart from these real numbers, are there any numbers that are non-real or they are unreal? So basically apart from real numbers, we have one more group of number, that is your imaginary number. So you might have seen numbers like root 2, right? This is your irrational number. But when I introduce a sign of negative inside your under root, so that becomes imaginary number, right? Minus root 2 is again a real number because the negative is outside the under root. But when we have negative inside of under root, that is known as your imaginary number. You will be learning about imaginary numbers in your higher standards. All right, so let's see that how are these numbers interrelated. So you might get questions like statement wise that every whole number is a natural number. So we know that all the whole numbers include a set of what? It includes a set of 0, 1, 2, 3, 4 and so on, right? These are your whole numbers. Secondly, over here is natural numbers. Natural number is a set of counting numbers, that is 1, 2, 3, 4 and so on. So basically the question is saying every whole number is a natural number. But from here I can say that 0 is a whole number. But 0 is not a natural number. So is this statement true that every whole number is a natural number? No. Why do we say no? Because 0 is a whole number, whereas 0 is not a natural number. Moving forward to the second statement. For the second statement we have every integer is a rational number. So integers includes a group of what? Negative numbers and positive numbers. Integers include a group of what? Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3 and so on. Right? This is what your integers include. Rational number includes all the numbers of the form p by q where q is not equals to 0. From here I can see that you can write 2 as 2 by 1. That will not change anything. You can write minus 3 as minus 3 by 1. So this is in the form of p by q where q is not equals to 0, right? So we can say that yes, all the integers come under your rational number, or we can say that every integer is a rational number. So this statement becomes true, that is, yes, this is a correct statement. The next statement, every rational number is an integer. If I give you an example, that is rational number, for example, if we have minus 1 by 2. Minus 1 by 2 is a rational number, right? But minus 1 by 2 is not an integer. Why? Because integers only include numbers like 0, 1, 2, 3, negative 1, negative 2, negative 500, but no fractional or rational numbers. So over here, this statement becomes false. So from here, we can see the relation. See, every integer is a rational number, but every rational number is not an integer. So we have to be very, up to the concept to crack such questions and to understand the language. Alright, so the next question says, is 0 a rational number? Alright, so we have a number that is 0. Now it's a complication because some students says that we cannot write 0 as 0 by 1. But why not? We can write 0 as 0 by 1. We only needed that the number should be of the form p by q and q should not be equal to 0. But they did not say that our p cannot be equal to 0. So since our q can be equal to 0 and I can write 0 as 0 by 1 and my p can be equal to 0 and q not equals to 0. So yes, 0 also forms a rational number. So 0 is also a rational number because we can write 0 as 0 divided by 1. Alright, let's move forward to the next question. The next type of question comes to calculate rational numbers between two given numbers. Right, how do we do such type of questions? See, we have one number as 3, other number as 4. First of all, I can write 3 as 3 by 1 and 4 as 4 by 1. Right, simply do what? The very first step, multiply. Since they have the same denominator, if they did not have the same denominator, what we would have done, we would have taken the LCM and then made the denominator same and then multiply. But since over here the denominators are already same, what we are just going to do, we are going to multiply the numerator and denominator by same number in both the cases. You can multiply it by 15, you can multiply it by 3, you can multiply it by 7, any number. But make sure that you multiply both the numbers with the numerator and denominator same. Right? So over here I needed 6 rational numbers, so I simply did it by 10. That is convenient. Right? That is easy to do. So this will become 30 by 10. This will become 40 by 10. Now very easily what you can do, you can calculate 6 numbers between 30 by 10 and 40 by 10. That is 31 by 10, which is also equals to 3.1, because you know that between 3 and 4 there comes 3.1, 3.2, 3.3, right? So next number will be 32 by 10. Next will be 33 by 10. Next will be 34 by 10. Next will be 35 by 10, and the other will be 36 by 10. So these are the numbers that we can take. These are the 6 numbers that will come in between 3 and 4. I hope this thing is clear. Let's move forward to our irrational numbers. So we have already had a word about rational numbers, all the numbers that can be expressed in the form of P by Q. So irrational numbers basically that do not have a terminating decimal expansion. Now what are these terminating and non-terminating decimal expansions? We are going to read about it. But when we talk about irrational numbers, so numbers such as root 2, root 5, 3 minus root 2, 6 plus root 5, and even pi forms your irrational number. Now certain times students get confused for this pi, right? So they say what? That ma'am, pi has values such as 3.14 and 22 by 7. 3.14 can be written as 314 by 100. So why do we say that it is an irrational number, whereas it can be expressed in the form of P by Q? So here students, when we talk about pi values, these are the approximate values of pi. That's why they are what? Your rational numbers. But when we talk about pi as an individual, it is an irrational number. So if the question comes like, is pi an irrational number? So you have to say that yes, pi is an irrational number. When the question comes like, is 22 by 7 an irrational number? So we have to say no. 22 by 7 is not an irrational number. Although we take the value of pi as 22 by 7, but those values are approximate values that we are taking. I hope this thing is clear, right? Let's move forward. Now the next thing that we have is to locate root numbers on number line. So keep one thing very clear in your mind. When you have to locate root numbers on number line, you have to be very clear with the Pythagoras theorem, right? So basically what is the main agenda by drawing this root 2 on number line is that basically we have to be very clear with the Pythagoras theorem. We have to anyhow take this root 2 on the hypotenuse so that we can draw it further, right? So basically if I imagine a right angle triangle, so if I do imagine a right angle triangle, right? If this is the right angle triangle that we have, and if this is A, B and C, right? Our first motive should be that whatever number we have to locate on the number line, that number should anyhow come on our hypotenuse. We should take our base and perpendicular in such a way. What I am saying, to get this root 2 on the hypotenuse, we have to think that what we can take on the base and the perpendicular respectively, so that root 2 comes on the number line, right? We know that hypotenuse is equals to under root of perpendicular square plus base square, right? If I need hypotenuse as root 2, what should I take as perpendicular and base? For example, if I take this as 1 unit and this as 1 unit, what we will get? See, under root of 1 square plus 1 square, which is equivalent to under root of 1 square is 1, 1 square is again 1, which is equals to under root of 2. So if I take my base as 1 unit and perpendicular as 1 unit, so straight away if I join the line between these 2 points, I will get my hypotenuse as root 2. Now how to apply it on a number line? Listen to me. For suppose this is the number line that you have, right? This is the number line that you have. Alright, let us take over here 0. Over here let us take 1, 2, 3 and 4. Alright, the very first step that you have to do, is from 0 to 1 make a line. From this 0 to 1 make a line, and this line will be equivalent to your 1 unit. From 0 to 1, it is 1 unit. The next thing that you have to do is, at this point, mark an angle of 90 degree, right? Or you can draw it too. You can mark it too. For example, you have marked angle of this as 90 degree. Just draw a straight line, and this line should also be equals to 1 unit. Now, according to my triangle, what I have done, I have taken the base as 1 unit, right, and taken the perpendicular also as 1 unit. So when I have taken the base and the perpendicular as 1 unit, so when I will join this point, let it be A, and this point, let this be B. When I join these points, so this line that I will be getting will be giving me what? Root 2. Will be giving me what? My root 2. Now simply what do we have to do? Now simply we have to take our compass. What we have to do? We have to take our compass, right? Keep the needle of the compass here on this A point and open the compass till B point. Now what will that do? When I'll take the compass and keep the needle at B, at A, and open up it till B, so I will get the opening of my compass as root 2. Right? Now from this root 2, which a compass is open, try to make an imaginary circle. Right? Try to make an imaginary circle. This. Right? Now what is the point of drawing the circle? Basically, listen to this concept very carefully. Right? If this is your root 2, and if I have opened my compass and draw a circle, right, so basically all the points from here to this circle will be of root 2 centimeter, right? That means if this point was root 2, if this particular line was root 2, and at this point the line is intersecting the number line, so I can say from A to this point of the circle, this particular line is what? This particular point will form my root 2 centimeter. So that is how, when we have drawn the root 2 as this, as a slant line. So how to bring this slant line on the number line? By taking it as a radius and drawing an arc, so that each and every point that circle follows gives us what are root 2 units. So that is how, so this point on the number line will be known as the point of root 2, approximately 1.414. That is the approximated value of your root 2. So this is how we can draw, right? Now if we have to draw root 3, for example, if we have to draw root 3, so we again have to think of a triangle, right? We again have to think of a triangle like this. So basically, how can we draw root 3? If I take my base as root 2 and my perpendicular as 1, see, what will be the hypotenuse? Which will be equal to under root of perpendicular square plus base square, which is equals to under root 2 square is 2, 1 square is 1, which will give me root 3. Now to draw root 3, we have to first of all draw root 2. Why? Because in the base we need root 2, and with a ruler and pencil we cannot draw root 2. So we actually have to do what? We actually have to draw root 2 in case if we want to draw root 3. Right? So basically what over here we can do is, we have drawn this root 2. Now on this root 2 at this point B, what do we actually need? We need to draw a right angle again, that is over here, and a straight line of 1 unit. So now in this particular thing, this point will be our base, that is root 2, and this will be our height, that is 1 unit, and this is 90 degree, right? So from here we can join this point D with our point A. Now this A and D, again we have to take the compass, open it and make an arc. So at the point where this arc touches the number line, that point will be known as your under root of 3. So by this we can draw any of the root numbers, any of the irrational numbers on the number line straight away, by doing what? By taking each and everything according on the base and the perpendicular, and seeing like how we can actually draw that thing on the hypotenuse, and what should we take on the base and the perpendicular. right? All right. So real number and their decimal expansion. So let us talk about it because we are already discussing about decimal expansion so much. So let's see what does this decimal expansion means. All right. So these are three numbers: 10 by 3, 7 by 8, and 1 by 7. Let us try solving it. This is 10 by 3. That simply means that we have to do 10 divided by 3. So when we do it, so we get 3 3s are 9 minus 1, 10. Decimal, 3 3s are 9 again, 1, 0, 3 3 and 9. So basically what I can see from here is that whenever I take 9, my remainder is 1. That will become 10. Again I am taking 9. So I can see over here that this decimal expansion will come out as 3.3333 and never ending. It will always come as 3333333. Right? This is one decimal expansion. Now let's talk about the second one. That is 7 by 8. That is 7 divided by your 8. So simply what we can take 0, then this will become 70 decimal. Now what we have to take, we can take 8 over here, right? 8 8s are 64 minus 06. Then we are left with 60. So I can say 8 7s are 56 minus 04. It becomes 40. So I can say 8 5s are 40. Now I get the remainder as 0. So basically this decimal expansion is 0.875. Right? As simple as that. Now the third number that I have is 1 by 7. That is 1 divided by 7. Right? This is 0.10. 7 ones are 7 minus 3, 30. 7 fours are 28 minus 02, 20. 7 twos are 14 minus 06, 60. Right? 7 eights are 56 minus 04, 40. 7 fives are 35 minus 05, 50. 7 sevens are 49 minus 01, 10. Now I can see that again I have 10. Again I have to take what? 1. So this will become 7. Then we will be having 3 again, then 30, then 28, then for 20 again. Right? So this is what I'm saying is basically this will come out repeatedly as 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7 and so on. So this will not end. Now just see these three types of decimal expansion very carefully and study them. In the very first decimal expansion, we can see that only one number is there which is repeating itself, right? That is 3.33333333 and so on. Right? Over here we can see that none of the number is repeating and we are getting the remainder as 0. So this is one kind of decimal expansion. And the third type of decimal expansion that we have is the same number is not repeating, right? Like in this case it was 33333, but in the third case we can see that the same number is not repeating itself, but what it is doing, a group of numbers is repeating itself, right? So basically these three are the type of decimal expansions that are seen in your rational numbers. So when we talk about rational numbers can show these might appear as 3, but these are basically 2 type of decimal expansion, right? This one which is ending and giving us a remainder as 0, such decimal expansion are known as your terminating decimal expansion. Such decimal expansion are known as your terminating decimal expansion. What is the meaning of terminating? Terminating means to end, right? Terminate means to end. So basically it is known as terminating decimal expansion because it is giving the remainder as 0. Now the first type of decimal expansion and the third type of decimal expansion are known as your non-terminating decimal expansion because this is not giving the remainder as 0. Non-terminating, and since they are repeating a lot of numbers or one single numbers after the decimal, right? Over here only 3 is being repeated. Over here 142587, 142587, 142587, 142587. This 142587 is repeating itself, right? So these type of decimal expansion are known as non-terminating recurring. Now what is the meaning of recurring? Recurring means repeating, because these decimal expansion are not ending, but they are repeating the same number again and again. So such decimal expansion are known as non-terminating recurring, right? So from here what I want to tell you is, simply we can say, right, that if we have rational numbers, when we talk about rational numbers, so rational number comes up with two type of decimal expansion. One is either they will give us a remainder 0, that is known as terminating decimal expansion, right? The second part over here is either they will not terminate, right? Either there will be non-terminating, either there will be non-terminating, but they will be recurring decimal expansion. But they will be what? They will be recurring decimal expansion. So these are the two type of decimal expansion that our rational numbers have. Alright, so over here we have 3.142678. We have to represent it in the form of P by Q. So we have already done this. If we have 3.3, let's see a smaller number. If we have to remove the decimal, we just divide it by 10. This will become 33 by 10. That is the P by Q form. Similarly over here, if I have to write 3, 1, 4, 2, 6, 7, 8 and have to remove the decimal, right? So I have to divide it by how many zeros? 1, 2, 3, 4, 5, 6. Why? Because I have to move the decimal 1, 2, 3, 4, 5, 6 places. So I will simply do what? I will simply divide this 314 and then I can simplify it also, cut it by 2 or leave it anyway. So this is what is a P by Q form for the decimal numbers. Easy. The next part, 0.33333 in P by Q form. Now this is what? This one was your terminating decimal, right? How can you say that? Because there are no dot dots like to be continued by the end of the number. Over here we have what? The number is ending. This is the number, right? But in the second case, we can see that this 3 is repeating itself. Over here we can see that we can divide the number by 6 zeros. Why? Because this number has an end. Over here I cannot even tell you that we have to divide it by 4, 3. No 4 zeros, no, because this 3 is never ending. So we cannot divide it by any 10, 100,000, 10,000 number like that. So in these cases, when you have a non-terminating decimal expansion, how do we convert it into the form of P by Q? Now see, over here, first of all, take this number as x. Whatever number is given to you, that is 0.33. And when we have a repeating number like 333333, we can call this number as, we can write this number as 0.3 and with a bar on it. Bar means repeating number, right? So over here I can write this as 0.3 bar and mark it as my first equation. Now, the second step is multiply both sides of the equation with the number of digits having bar on it. Over here only one digit is having bar on it. So multiply with a 10 number, that is multiply both sides by 10. So this will become 10x. This will become 3.3 bar. And why 3.3 bar, students? When we multiply any number, this is actually what? 0.3333 and so on. Multiplying it by 10 will shift the decimal to one place. So this will become 3.333 and I can write this as 3 bar. So simply it will become what? 3.3 bar. The second step that you have is subtract the first equation from the second equation. That is it. What you have to do, you have to subtract the very first equation from your second equation. Now let's do it. This will give me 10x minus x is equivalent to 3.3 bar minus 0.3 bar. This will give us 3.3 bar minus 0.3 bar. 10x minus 1x will give you 9x. 3.3 bar minus 0.3 bar. See, 3.33333333 endless minus 0.333333 endless. So those 3 will get cancelled out. So 3 bar and minus 3 bar cancel. We will be left with only 3. So x will be equals to 3 by 9 and that will give you 1 by 3. So basically 0.333333 endlessly can be written in the form of p by q as 1 by 3. One more example. Over here, we can see that two numbers are repeating. That is 27. It is 1.27272727272727 and so on. Now again, we can write taking this number as x and I can write this number as 1.27 bar. And now I have to put the bar on both the 2 and the 7. Why? Because both numbers are repeating themselves. This will be our first equation. Right, this will simply be our what? This will simply be our first equation. Right, for the next thing what we have to multiply both sides of this equation with a number of digits having bar on it. Having seen this 1.27, we can say that 2 and 7 both have a bar on it, that is 2 numbers. So I can multiply both the side by 100 and your 100. So this will become what? 100x and this will become what? 127.27 bar. Now again what we have to do, students, we have to subtract. This will be our second equation. We have to subtract the first equation from the second equation. That is 100x minus x is equals to 127.27 bar minus 1.27 bar. Right, 100x minus x will give you 99x. 127.27 minus 1.27 will give you 126. As 27 bar and 27 bar will get cancelled out, 127 minus 1 will give you 126. So x will be equals to 126 by 99. You can simplify it by 3. 3 4s are 12, 3 2s are 6, 3 and 3. Again, you can solve it by 3. This will give you 11. This will give you 14. So basically, you can write this number as 14 by 11. That is 14 divided by 11 will be the P by Q form of this particular number that we have. I hope this thing is clear with everyone. Right? Let's move forward to the next thing. Find an irrational number between 1 by 7 and 2 by 7. So getting a rational number is really easy. We have already done. If the denominator is same, we take the direct multiplication thing and just calculate it. And when the denominators are not same, we take the LCM and then we do. Right? But when we have two numbers and we have to calculate an irrational number between two given rational numbers, how do we do it? Right? First of all, we just take the approximate decimal expansion of these numbers. 1 by 7, as we have already done, this will give us somewhere around 0.14. As we have already done the division, right? As we have already done the division for 1 by 7, this will give us 0.1428 approximately. Right? 0.1428. And similarly, 2 by 7, that means 2 into 1 by 7 and 1 by 7 has this decimal expansion. So 2 into 0.1428 something 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 will give us a decimal expansion of 0.284 something something approximately. Now you have decimal expansion 0.14 and this is 0.28, right? So basically in between 0.14 and 0.28 there are multiple numbers are like 0.15, 0.16, 0.17, 18, 19 and so on, right? So you just have to choose one number. For example, I chose 0.17. Now you have to write this decimal expansion in such a way that the numbers are not repeating and are not terminating. What you can do? You can write this as 0.171, right? 1771, 7771 and so on. So how we can see the pattern? Over here it was 17, right? 17. Over here it is over here it is 171. Over here it is 1771. Over here it is 17771. The next number will be 177771. So there is no number which is repeating, right? No pattern, no single number that is repeating itself, right? And there is no group of number that is repeating itself. So such decimal expansion is of your irrational number. You can take 0.180, 1880, 18880 and so on. This is again a non-terminating and a non-recurring decimal expansion because no number is constantly repeating it, neither nor a group of number is repeating itself. So this is what a decimal expansion of irrational numbers, and that's how you can straight away write the decimal expansion of an irrational number between any two numbers that are given to you. Alright, let's see what is the next thing that we have over here is, okay, so we have to classify the following numbers as rational or irrational. So over here we have root 23. Of course it's an under root, so it is an irrational number. Second is under root of 225. We can write this under root of 225 as 15, right? Because 225 is 15 square. Square and root will get cancelled out and this will become our rational number. 0.3796. Since we can see that this is a terminating decimal expansion, no number is repeating and we are having an end for this decimal expansion. So this is of our rational numbers. Now this is 478, 478 and so on if we take it. So this is again non-terminating but repeating. Why repeating? Because 478, 478 is repeating itself. So this becomes a decimal expansion of rational numbers. Now this is 10, 100, 1000. So again we can see no numbers are repeating, no pattern is formed, no group of number is repeating. So such decimal expansion is of irrational numbers. I hope this thing is clear with everyone. So let's move forward to the next part, that is operations on real numbers. Now what are these operations on real numbers? Let's talk about it. What are the different type of addition and subtraction which follows? The very first is when we have to add two given irrational numbers. One is simply 2 root 2 students plus 5 root 3. The other one is simply root 2 minus 3 root 3 and we have to add both of them, right? So what we can do, just consider these root number as variables, right? Likewise we do that 2x plus 1x gives us 3x. So similarly we have to see that which of the following numbers have the same root with them. So 2 root 2 and this root 2 have same root with them. So let us write them together. Then this 5 root 3 minus 3 root 3, they have the same roots. Now how to solve them further depends totally on the variable part again. For example, just relate to this. For example, you have 2x plus 3y minus x plus 6y. So from here what you can do, you can add these two and you will simply get 1x. You will add these two and you will simply get 9y and you will leave the answer over here because these cannot be solved further because these are two different variables. Consider the under roots as same. Over here 2 root 2 plus root 2. 2x plus 1x will give you 3x, right? So similarly 2 root 2 plus 1 root 2 will give you 3 root 2. This is how you solve it. 5 root 3 minus 3 root 3. Consider 5y minus 3y. 5y minus 3y gives you what? Simply gives you what? 2y, right? Similarly 5 root 3 minus 3 root 3 will give you simply 2 root 3. So this will be the final answer. You cannot solve it any further because the under roots are different, or you can say the variable sort of part is different. Right? For example, over here we have multiply 6 root 5 by 2 root 5. Now as we know that x into x gives us x square, right? Same goes for here in multiplication. 6 root 5 into 2 root 5. Firstly, we will multiply the normal constant number. 6 into 2, that is 12. Then I multiply root 5 into root 5, x into x, x square. Root 5 into root 5, root 5 square. That will give you 5. So 12 into 5, so the answer will come out to be 60. So this is how you multiply and this is how you add them up. In addition, you have to take care of this but not in multiplication. The next thing, we have to divide. Now how can we divide? This is 8 root 15, right? This is 2 root 3. We can divide the numbers by numbers, right? Like 2 by 8 and root 3 by root 15 separately. You cannot just cancel 2 by 15, root 15, no. Just make sure you cancel 2 by 8, that will give you 4, and separately you cancel root 3 by root 15, that will give you root 5. That will give you root 5. So the answer will be 4 root 5. So when you cancel, you will just simply cancel, like 3 5s are 15, so 3 5s are 15, but there is an under root in both of them, so you have to apply that under root in the quotient as well. So this will give you 4 root 5 and this will be the final answer. Alright, so there are further operations that under root of AB is equals to under root of A into under root of B. This means what? For example, we have under root of 6. This 6 can be written as under root of 2 into 3. We can write 6 as 2 into 3 and this will give us root 2 into root 3. So basically, if we have a whole number in the under root, we can write it as a product of its prime or product of any two numbers basically in different roots. This is what our law of operations says. The second one is we can distinguish, we can separate the division sign of the under root as well. For example, if we have under root of simply 8 by 15, so we can write this as under root of 8 separately and under root of 15 separately as well. The next thing that we have is under root of A plus under root of B. This is as simple as A plus B, A minus B identity, where A will become root A and B will become root B. So we know that A plus B, A minus B is the identity of A square minus B square. Over here, A is under root A square minus B is under root B square. So we can simply say that under root of A square will give you what? A. Under root of B square will simply give you what? B. So this will be equivalent to A minus B. Right? Alright. The next thing, A plus root B, A minus root B. Now A is A, so it will become A square. But B is root B, so it will become B only. Because root B square will give you B only. Alright, so under root of A plus under root of B. Now this is nothing but just the multiplication of binomial with binomial, and that is it. Root A into root C, root A into root D, root B into root C, and root B into root D. Just a binomial with binomial multiplication, nothing else, right? Okay. Let's solve it up. Simplify the following expression. Over here we can see that the expression is 5 plus root 7, 2 plus root 5. So both the numbers are different from each other. No identity is applied. Simply what you have to do, multiply the first number with both the numbers of second bracket and the second number of the first bracket with both the numbers of second bracket. So 5 into 2 will give you 10. 5 into root 5 will give you 5 root 5. Root 7 into 2 will give you 2 root 7, and root 7 into root 5 will give you under root of 35. So this will be the final answer, as this cannot be solved out any further. So this is how you are going to do it. The next thing that we have is 5 plus root 5 and 5 minus root 5. We can clearly see that there is a pattern of identity, that is A plus B and A minus B, where A is 5 and B is equals to root 5. As simple as that, right? So A plus B, A minus B, where A, so this will become A square minus B square. 5 square is 25. Root 5 square is 5. So the answer will come out to be 20. The answer will come out as simply, that is your 20. I hope this thing is clear. Let's see the next question. Root 3 plus root 7 whole square. This gives us an identity of a plus b whole square, which is equals to a square plus b square plus 2 into a into b. Right? So root 3 square will give you 3, root 7 square will give you 7, and over here is root 7 into root 3 will give you what? Root 21 into 2 will give you 2 under root 21. 7 plus 3 will give you 10 plus 2 under root 21. You can either take the 2 common, so we will have 5 plus under root of 21 as the answer. That is it. Alright, now let's talk about rationalization. In this chapter, this topic is again important. And what is the actual purpose of rationalization, students? To actually eradicate and remove the under root from our denominators. Right? Let's do it. For example, we have to rationalize this. Before this, let's do an easy example. For example, we have to rationalize 1 by root 2. So when you have only one under root term in denominator and it is only a single digit number, no operations, that is plus and minus signs are involved, simply what you can do, just multiply the numerator and denominator with the same number. That is it. So 1 into root 2 will become root 2 and root 2 into root 2 will become 2. So this is how you can rationalize when only a single digit number is available in the denominator. But in case you have two numbers, right, with an operation in between, over here we have addition. How to solve this one? Right? So you have to multiply both the numerator and denominator with the same digits. With the same digits, but just make sure if there is addition in between, over here you have to take the subtraction. And if you have a subtraction in between, we would have taken the addition sign. Right? Now just multiply 1 into 2 minus root 3 will give you 2 minus root 3. And over here it will become 2 plus root 3 and 2 minus root 3. Our actual purpose of taking the opposite sign was just to make sure that when these denominators are multiplied, they form an identity of a plus b and a minus b. So what we can simply do, we can simply use the identity of a square minus b square. So this will give us 2 minus root 3. 2 square is 4, root 3 square is 3. So this will give me 2 minus root 3 divided by 1. Right? So this will simply give us 2 minus root 3 divided by 1. This is how it is done. Alright. For example, we have a difference operator in between. So this is 5, root 3 minus root 5 into root 3 plus root 5 upon root 3 plus root 5. Now simply what we can do, students, we will take this as 5 into root 3 plus root 5 over here divided by root 3 minus root 5 in one bracket and root 3 plus root 5 in another bracket. So what we can do over here is simply multiply this inside. So this will become 5 root 3 plus 5 root 5 in the numerator. A minus b, a plus b. Again the identity of a square minus b square. Right? So this will give me what? 5 root 3 plus 5 root 5 divided by root 3 square is 3, root 5 square is 5, and we will get a negative sign. Right? So this is how we can rationalize it when we have difference operator in between. I hope rationalization is clear with everyone. Right? Let's move forward for the laws of exponents. Now laws of exponents is something that we have already done in our junior classes, that basically if we have a to the power m into a to the power n, this will give us a to the power m plus n. This means what? 2 to the power 2 into 2 to the power 3. Multiply. So we can write this as 2 to the power 5, that is 2 plus 3. The next thing that we have is a to the power m whole to the power n. For example, if we have a number that is 3 to the power 2 whole to the power 6, so this will become 3 to the power 12 because these two numbers will be multiplicated. Next, we have the difference, that is division. For example, if we have 5 to the power 6 divided by 5 to the power 2, so this will become 5 to the power 6 minus 2, which is equals to 5 to the power 4. So when it's in division, we subtract them, right? The next we have is if the two numbers are different but have a same power, so we can write it as collective. That is 2 to the power 3 into 5 to the power 3 can be written as 2 into 5 to the power 3, that is 10 to the power 3. This is how we can do it, right? Let's solve some question. 2 to the power 2 by 3 into 2 to the power 1 by 3. So we can see a relation that a to the power m into a to the power n is equals to a to the power m plus n. This will give us 2 to the power 2 by 3, students, into 2 to the power 1 by 3 will be equal to 2 to the power 2 by 3 plus 1 by 3. That will give us what? 2 to the power 3 by 3, that is 1. This is equals to 2 to the power 1, which is equals to 2 itself. So this is how we can solve any operations, right? Any expression that we have by our laws of exponents. The next thing that we have is, see, now this is of the form a to the power m whole to the power n. This will give us what? A to the power m into n, that is 1 by 5 into 4, that is equals to 3 to the power 4 by 5, right? This means 3 to the power 4 by 5 will be the answer. Next we have is 7 to the power 1 by 5 divided by 7 to the power 1 by 3. Now this is of the form a to the power m upon a to the power n, students, and this was equals to a to the power m minus n. So this will be of the form 7 to the power 1 by 5 divided by 7 to the power 1 by 3 will be equal to 7 to the power 1 by 5 minus 1 by 3. We have to take the LCM. That will give us what? 7 to the power, LCM will be 15. 5 and 3 will give the LCM of 15. This will become 3. This will become 5, which is equals to 7 to the power minus 2 by 15. So this will be the answer to this particular question. Alright, so over here, now the powers are same but the bases are different. So this is of the form a to the power m into b to the power m, which is equals to a into b to the power m. So over here we can write 13 into 17 2 to the power 1 by 5. We can multiply it and write it as the power of 1 by 5. This can be, this is multiplication, right? Okay. Now 64 to the power 1 by 2. So 64 can be written as 8 square and this is power 1 by 2. Now this is of the form a to the power m whole to the power n, which is equals to a to the power m into n. Right? So what we can see over here is 8 to the power 2 into 1 by 2, which will give us a to the power 1 or simply 8. Next we have 32 to the power 1 by 5. Now this 32 can be written as 2 to the power 5, as 32 is 2 to the power 5, 2 into 2 into 2 into 2 into 2, and then we have whole power as 1 by 5. Now this is of the form a to the power m whole to the power n, which is equals to m to the power m into n. 5 and 5 cancel. So the answer will be just 2. Alright. Next we have what? Different powers but same bases. A to the power m into a to the power n equals to a to the power m plus n. So we just simply have to what? Add the powers. Again it's 2 and 3. So the LCM will be 15. Over here it will be 10. Over here it will be 3. So this will give me 2 to the power 13 by 15. Just take the LCM, add them up, right? All right, over here. So we have over here what? If root 3 is 1.732 and root 3 is 1.414, find the value of 1 by root 3 minus root 2. So instead of applying the direct value, first rationalize. That will help you a lot. Root 3 plus root 2 divided by root 3 plus root 2. In the numerator, we will be having root 3 plus root 2. Right? If you would have applied the direct value, that will come in rational form, right? And then again, you have to divide it by 1 to get the exact answer from these options. So over here, just rationalize it first. A minus b, a plus b, a square, that is root 3 square, that is 3, b square, that is root 2 square, that is 2. So we are just left with root 3 plus root 2, that is equals to 1.732 plus 1.414, that will give us what? 3.146, option number B. So this is how we approached the question. So since we got the values, but these values are of course the approximate values, and if I have a number over here, so just rationalize it, solve it up, and you can get the answer for the same. The next thing that we have over here is a rational number lying between root 2 and root 3, right? Simply we have to calculate a rational number between root 2 and root 3. Will not be a root 6, will not be 1.6, because over here this, right? So we have to first of all calculate the rational numbers, right? So out of these 4 options, I would love if you can get the answer in the comment section down, so that I can give you this question as a homework question. Try to apply some brains, try to get the approximate value, right? And just apply it. Will you get the answer or not? Whether it be root 2 plus root 3 by 2, whether it be root 6, 1.6, 1.9, you can actually calculate the approximate value for 1.6 as well. So this was all for your chapters, that is number systems, and I hope that all the important topics are clear. How to give an approach to the question is clear, and I hope that each and everything that we have done in this particular lecture actually helps you to do more questions from the chapter number systems, right? If you have any doubt, so 2 things you have to comment. First of all, the homework question, and secondly, if you have any more doubts from this chapter. So I will be more than happy to help you guys. Thank you so much and take care. Bye bye.